Prepare to relax, and let us begin our journey. Introduction. A departure from the familiar. Let us begin by finding a comfortable position. Allow the weight of your body to settle. Feel the gentle pull of Earth's gravity, a constant, familiar embrace that has held you your entire life. Take a slow, deep breath, and as you exhale, let go of the day. Let go of the bright blues and sharp whites of our terrestrial world. Tonight, we will not stay here. Our minds are capable of traveling unimaginable distances, faster than any ship, faster even than light itself. We are going on a voyage to the shores of other worlds, to the top 5 known exoplanets that whisper the tantalizing possibility of life, all nestled within our cosmic neighborhood. This is not a journey of hard data and complex charts. It is a journey of sensation, of imagination grounded in scientific discovery. We will feel the alien gravity, gaze upon skies of crimson and ochre, and stand on landscapes sculpted by forces both strange and familiar. We will compare these worlds to our own Earth, not to judge them, but to better understand the quiet miracle of our own home and the breathtaking diversity of the cosmos. Let your mind grow quiet, the journey is beginning. We are lifting away from the gentle hum of human life, rising through our atmosphere, a veil of blue that fades to the profound black of the void. Earth, our perfect, swirling marble of life, shrinks below a precious beacon in the infinite dark. We leave the light of our golden sun behind and venture forth into the quiet, starlit dark. Part 1. The closest shore. Proxima Centauri. A journey of 2 light years. Our first destination is also our nearest neighbor. It is a journey of over 40 trillion kilometers, a distance so vast that our fastest probes would take tens of thousands of years to cross it. But for us, in this moment, it is but a single, peaceful thought away. We are drifting towards a faint, red star, a tiny ember in the cosmic night named Proxima Centauri. This star is not like our sun. Compared to the brilliant, life-giving furnace at the center of our solar system, Proxima Centauri is a mere candle flame. It is a red dwarf, ancient and moody. If you were to place it beside our sun, the sun would be a grand, golden bonfire, while Proxima would be a small, smoldering coal, glowing with a deep, ruby light. It possesses less than 1/10 of the sun's energy, and its light is gentle, cool, and overwhelmingly red. As we draw closer, we see that this small star is not alone in the sky. In the distance, 2 brilliant points of light shine like a pair of celestial eyes. They are Alpha Centauri and B, the 2 larger companion stars in this system. From our destination, they would appear as 2 impossibly bright stars, a permanent fixture in the night sky, far brighter than Venus ever appears to us on Earth. And there, circling its dim, red parent, is our destination, Proxima Centauri b, a world of perpetual twilight. We descend now through the thin, speculative layers of its atmosphere. The first thing we notice is the light. The light here is not the white, old of an earthly noon. It is a permanent, deep, and somber crimson. Imagine the last 5 minutes of a perfect sunset on Earth, when the world is painted in hues of copper and blood range. On Proxima b, this is the color of midday. It is a world bathed in an eternal dusk. We land softly on its surface. Let us feel the ground beneath our feet. The planet is slightly more massive than Earth, with a gravity about 10 stronger. It is not a crushing weight, but a gentle, persistent pressure. You would feel a little heavier, more solidly planted. Each step would feel more deliberate, more connected to the world beneath you. A stone tossed in the air would fall back a little faster, a silent reminder that this is a world with a stronger heart than our own. Now, let us look at the sky. Above us, the red sun, Proxima Centauri, hangs motionless. It does not rise, and it does not set. This is because Proxima b is tidally locked, a cosmic dance that has left it with one face perpetually turned towards its star and the other perpetually turned away. It is the same way our moon always shows the same face to Earth. This tidal lock carves the planet into 3 distinct and utterly alien realms. The day side, a realm of unblinking fire. Let us first imagine the side forever facing the star. Here, the dim red sun never moves from its position in the sky. For millions, perhaps billions of years, it has baked this landscape. There is no night, no reprieve. If there is no atmosphere to shield it, temperatures could be hot enough to sterilize the very rock. It would be a silent, reddish desert, a landscape of cracked earth and dunes of rust-colored dust under a sky that never changes. It is a place where time itself seems to have stopped. Compared to Earth, with its gentle cycle of day and night, its sunrises and sunsets that mark the passage of our lives, this side of Proxima b is a place of stark, unchanging permanence. The night side, a kingdom of absolute cold now. Let us drift to the opposite hemisphere, the side that has not seen direct light in eons. The cold here is absolute, a depth of freezing that makes Earth's polar night seem balmy. It is a darkness more profound than any cave on our planet. The only light comes from the stars and from those two brilliant, distant diamonds, Alpha Centauri and B, which would cast faint, eerie shadows across a landscape of frozen nitrogen and carbon dioxide. Here, the very air would be frozen solid, a silent, crystalline world of ice under a sea of stars. Earth's coldest Antarctic night is a place of bustling life in comparison. The Terminator line, the cradle of possibility, but between these two extremes lies the most interesting region of this world. It is a strip of land that circles the globe, a zone of perpetual twilight known as the Terminator line. Here, the red sun hangs forever on the horizon, as if it is eternally rising, or eternally setting. Let us stand here, on a rocky ridge in this twilight zone. On one side of the sky, the world is bathed in the deep red glow of the star. On the other, the sky fades into impenetrable black, dotted with stars. The temperature here is moderate, potentially allowing for the most precious substance in the universe, liquid water. The greatest difference from Earth in this twilight zone would be the wind. An immense, powerful, and relentless wind would blow constantly from the hot day side to the cold night side. It would be a global river of air, a force that would shape everything on this world. Mountains would be eroded into long, streamlined shapes, all pointing away from the sun. The sound of this wind would be the planet's heartbeat, a constant moan or a high-pitched shriek, the sound of a world forever trying to find balance. On Earth, we have storms and breezes, but here, the wind is a permanent feature of the landscape itself. If life exists on Proxima b, it is likely here, in this sliver of dusk. Imagine plants, not green like Earth's, but a deep black or a dark purple, evolved to soak up every last bit of energy from the dim, red sunlight. Imagine creatures that stay low to the ground, built to withstand the never-ending wind, with senses adapted to a world of low light and long shadows. But there is a danger here. Proxima Centauri is a flare star. Periodically, and without warning, it erupts with violent bursts of radiation. On Earth, our magnetic field and thick atmosphere protect us from our sun's flares, creating the beautiful spectacle of the auroras. On Proxima b, these flares would be thousands of times more powerful. They would score the surface with rays and charged particles. Any life here would need to be incredibly resilient, perhaps living underground, or in the depths of a hypothetical ocean, shielded from the fury of its own sun. Let us rest here for a moment, in the crimson twilight of Proxima b. Feel the gentle, extra weight of its gravity. Listen to the sound of the eternal wind. Gaze at the motionless red sun on one horizon, and the brilliant twin stars on the other. This is not Earth. It is a starker, harsher, yet strangely beautiful world. It is our closest exoplanetary neighbor, a silent testament to the fact that even in the nearest corners of the cosmos, worlds exist that defy our earthly expectations. Now, let us pull our consciousness back, across the void, leaving this world of eternal sunset behind and prepare for our next destination. Part 2, the Celestial Family, the Trappist-Un System, a journey of 40 light years. Our next journey takes us further, to a distance of nearly 41 light years. We are seeking another red dwarf star, even smaller and cooler than Proxima Centauri. This star is named Trappist-Un. It is an ultra-cool dwarf star, so small that if it were placed in our solar system, it would be only slightly larger than the planet Jupiter. Its light is even dimmer, a faint cherry-red glow, a dying campfire in the vast darkness. But this tiny star holds one of the most astonishing discoveries in modern astronomy. It is the sun to a family of at least 7 planets, all similar in size to Earth. It is a miniature solar system, so compact that all 7 of its worlds could fit comfortably within the orbit of Mercury. We are descending towards this remarkable system now. The planets are huddled close to their parent star and close to one another. Their years are incredibly short. The innermost planet completes its orbit in just 5 Earth days. The outermost takes a little over 18 days. Imagine a place where a year is shorter than a month on Earth. The passage of time here would feel dizzyingly fast from our perspective. Our destination is the heart of this system's habitable zone. We are aiming for a specific world, TRAPPIST-Ni, considered by many to be the most promising candidate for life in this entire system. A world with 7 moons. As we arrive in orbit around TRAPPIST-Ni, the first thing that strikes us is the view. This is perhaps the most profound difference from our own earthly experience. From Earth, our sky is dominated by one sun and one large moon. But here, the sky is a family portrait. Looking up from the surface of TRAPPIST-Ni, the other planets would not be mere points of light, like Venus or Mars are to us. They would be magnificent, looming disks in the sky. You would see your sibling worlds passing overhead, some appearing larger than our own moon. You could see the weather patterns on their surfaces, the glint of ice caps, the division between their day and night sides. It would be like having 6 other moons, each a world in its own right, engaged in a slow, silent and majestic dance across the heavens. This sky, you would be one of the most awe-inspiring sights in the known universe, a constant reminder that you are part of a grand, interconnected system. The gentle glow of TRAPPIST, or now, let us consider the light. The star, TRAPPIST-Hone, hangs in the sky, again likely motionless due to tidal locking. It appears larger in the sky than our sun does from Earth, because the planet orbits so closely. But despite its size, its light is weak. The overall brightness on the surface of TRAPPIST-Ni at midday would be similar to Earth's twilight, just after the sun has set. It is a world of perpetual low light. The color of this light would be a soft, salmon pink or a pale orange. It would filter down through the atmosphere, bathing the landscape in a gentle, warm glow. It is not the harsh, analytical light of our sun, which casts sharp shadows and reveals every detail. This is a softer, more dreamlike light, a light that would make the world feel intimate and enclosed. A world of water. Let us descend to the surface. TRAPPIST-Ni is almost exactly the same size as Earth, and its gravity would feel comfortingly familiar. A step here would feel just like a step at home. But the composition of this world might be very different. Scientific models suggest that the planets in this system, especially those in the habitable zone, could be incredibly rich in water. Let us imagine we are standing on the shore of a vast, calm ocean on TRAPPIST-Ni. The water is not the deep blue of Earth's seas. Under the pale orange light of its star, the ocean would appear coppery, or perhaps a deep, murky purple. The waves would lap gently against a shore of dark, volcanic sand. The air here might be thick and humid. With a potentially vast ocean and only gentle light, this could be a world of mist and fog. Imagine a landscape shrouded in a perpetual, warm mist, where visibility is low and sounds are dampened. It would be a quiet, mysterious world. Unlike the windswept vistas of Proxima b, TRAPPIST-Ni could be a place of profound stillness and humidity, a global sauna under a dim, orange sun. Life in the dim Red Sea, if life were to emerge here, it would be profoundly shaped by this environment. On Earth, life in the oceans is powered by sunlight penetrating the blue waters. Here, the red light from the star would not penetrate the water as deeply. Life might huddle in the shallow regions, or it might not rely on photosynthesis at all. Perhaps like on the floor of Earth's deepest oceans, life here would cluster around hydrothermal vents, drawing energy not from the sun above, but from the heat of the planet's core below. These hypothetical oceans would be vast and deep, potentially containing many times more water than all of Earth's oceans combined. This planet could be a true water world, with very little or no exposed land, just one single, globe-spanning ocean. On such a world, life would be purely aquatic, perhaps evolving into forms we can barely imagine, swimming through the silent, copper-colored depths, their only sky filled with the ghostly shapes of their neighboring worlds. The cosmic dance and the angry star life here would also be shaped by the close proximity of its siblings. The planets of TRAPPIST were in what is called orbital resonance. They pull on each other with their gravity in a regular, rhythmic pattern. For every 2 orbits of the outermost planet, the next one completes 3, the next one 4, and so on. This constant gravitational tugging and pulling would knead the planets, generating immense heat in their cores. This could lead to incredible volcanic activity, making these ocean floors alive with hydrothermal vents, perfect cradles for life. But, like Proxima Centauri, TRAPPIST-1 is a volatile red dwarf. It is prone to powerful flares. A planet so close would be blasted with radiation. An atmosphere, and a magnetic field would be essential for survival. But even more important would be the ocean. The global ocean, tens or hundreds of kilometers deep, would be the perfect shield, protecting any life in its depths from the fury of the star. Let us rest now, on this imaginary shore of Trappist-knee. Feel the familiar gravity. Breathe in the thick, misty air. Watch the gentle, coppery waves. And look up at a sky unlike any other, where giant, silent worlds drift past like celestial ships in the night. This is a world defined not by solitude, like our Earth, but by family. It is a world where the sky itself tells you that you are not alone. Let this peaceful image fill your mind as we now retreat back into the quiet of space. Part 3, The Heavy World. Wolf 1061's a journey of 14 light years. Our third voyage is shorter, a mere 14 light years from home. We are traveling to another red dwarf system, this one named Wolf 1061. This star is somewhat larger and brighter than Proxima Centauri or Trappist-own. It is also known to be exceptionally stable for a red dwarf, less prone to the violent, life-sterilizing flares of its smaller cousins. This quiet nature makes its system a place of great interest. We are aiming for the second of its 3 known planets, Wolf 1061c. This is not an Earth. Win in size. This is a different class of planet altogether. It is a super-Earth. As we approach, we see a world significantly larger than our own. It has a mass over 4 times that of Earth, and its diameter is perhaps 1.5 times as wide. It is a Titan, a world with a deeper gravitational well and a more substantial presence. A world of weight and pressure. Let us imagine ourselves descending onto its surface. The experience of gravity here would be the most immediate and profound difference. It would be nearly twice as strong as on Earth. This is not an uncomfortable, crushing force, but a constant, undeniable heaviness. Your body would feel heavy, your movements slower, more deliberate. Lifting your arm would require a conscious effort. Walking would feel like trudging through shallow water. A simple jump would be a monumental effort, and you would return to the ground with a solid, grounding thud. This pervasive gravity would shape everything. On Earth, our mountains can soar to incredible heights like Everest, scraping the edge of the atmosphere. But on a high-gravity world like Wolf 1061c, mountains would be crushed under their own weight. The landscape would likely be much flatter, more subdued. Hills would be gentle and rolling, mountains would be broad and powerful, like immense sleeping beasts rather than sharp, jagged peaks. Trees, if they existed, would need to be incredibly strong and thick at their base to support their own weight, perhaps not growing very tall at all. Flying creatures would be an evolutionary marvel, requiring immense power and huge wings to fight against the relentless pull of the planet. A realm of steam and heat. Wolf 1061 orbits on the very inner edge of its star's habitable zone. It is close enough to its star that it receives a great deal of warmth. This, combined with its greater mass, which allows it to hold onto a thick atmosphere, creates the potential for a runaway greenhouse effect, much like on Venus. But let us imagine a more optimistic scenario. Let's imagine a world with a balanced atmosphere, a world of warmth and water. This would be a tropical paradise on a planetary scale. The air would be thick, warm, and saturated with moisture. Great, dense clouds would permanently shroud much of the sky, creating a diffused, humid light. We are standing now in a vast, steamy jungle. The air is heavy and hot, smelling of rich soil and strange, alien blossoms. The gravity makes the very air feel thick and substantial. Rain on this world would not be a gentle pitter-patter. Each drop, pulled down by the powerful gravity, would fall faster and harder, striking the ground with the force of a small pebble. A rainstorm here would be a deafening, percussive event, the sound of a billion tiny hammers on the jungle canopy. The oceans would be warm, like bathwater. Due to the high gravity, waves might be smaller and closer together, the surface of the sea having a choppier, more textured appearance than the long, rolling waves of Earth's oceans. A red-hued sky, a faster year. The year on Wolf 1061's is short, just under 18 Earth days. The seasons, if they exist at all, would fly by in a matter of days. This rapid cycle would create a different rhythm of life, a faster pace of growth and decay compared to the long, languid seasons of Earth. Looking up from our steamy jungle, the sun, Wolf 1061, would appear as a large, orange-red disk. Being on the inner edge of the habitable zone, the planet is likely tidally locked. Once again, we find ourselves in a world with a permanent day side, a permanent night side, and a temperate band of twilight in between. In this twilight zone, the heat would be less intense. Here, the great, humid jungles might give way to vast, misty swamps. Rivers, pulled by the heavy gravity, would flow with incredible force, carving deep and powerful channels through the landscape. Waterfalls would not cascade gracefully, they would plummet with thunderous, terrifying power. Life on this super Earth would be built for strength. Skeletons would need to be thicker and more robust. Muscles would need to be more powerful. Life would be low to the ground, stout and strong. It would be a world of armored creatures and thick, arced plants, all evolved to withstand the immense and ever-present force of the planet's own heart. Let us pause in this heavy, humid world. Feel the weight in your limbs, the warmth on your skin. Listen to the roar of a powerful, gravity-fed waterfall in the distance. This is a world of substance, of power, of pressure. It reminds us that our Earth exists in a delicate gravitational balance, light enough for mountains to soar and birds to fly with ease. Wolf 1061 shows us a different path, a world built on a foundation of immense strength. As we leave this world of gentle giants, we carry with us the feeling of its powerful embrace, returning now to the weightlessness of our mental journey. Part 4. The Gentle Twin Teegarden Starbar Journey of 12. 5 light years. Our fourth destination brings us to a world that, on paper, is one of the most Earth-like planets ever discovered. We travel 5 light years to a very old, very quiet red dwarf star named Teegarden Star. This star is ancient, perhaps 8 billion years old, nearly twice the age of our own sun. It has long since passed its turbulent youth of violent flares. It is now a calm, stable and predictable star, making its planetary system a potentially peaceful heaven for life. We are approaching its innermost planet, Teegarden Star B, and as we draw near, we are struck by its profound familiarity. Its mass is estimated to be only 5 greater than Earth's. It is, for all intents and purposes, a true Earth-sized twin. This planet holds the distinction of having one of the highest Earth similarity index ratings ever calculated. The SE is a scale from 0 to 1, where 1 is a perfect Earth. Teegarden Star B scores a 0, 95. We are approaching what might be the closest thing to a second Earth we have ever found. A world of familiar feelings let us descend through its atmosphere. The pull of gravity as we land is almost indistinguishable from home. It is a subtle difference you might not even notice, a feeling of being just slightly more settled. A walk across its surface would feel natural, comfortable, familiar. The very foundation of your physical experience of this world would be like returning home after a long journey. The planet orbits its star in just 9 days. A year here is less than a week on Earth. This incredibly short year is spent entirely within the star's habitable zone. Scientists have calculated a high probability that this planet has a temperate surface, where liquid water could flow freely. Let us imagine ourselves standing on a hillside on Teegarden Star B. The temperature is pleasant, a comfortable 28 degrees Celsius or 82 degrees Fahrenheit. The gentle breeze, unburdened by the extremes of a tidally locked world, whispers through strange, alien grasses. An ocean planet under an ancient sun. The star, Teegarden, is a dim red dwarf, but the planet orbits it closely. The light would be soft and reddish, perhaps the color of a pale Ross wine. It would cast long, soft-edged shadows across the landscape. Let us look out from our hillside. Below us lies a vast ocean. Given the planet's age and stability, it is highly likely to have retained a significant amount of water. We see the pale red light of the star glittering on the surface of the water, a million tiny points of coppery light. The sky above is not blue. An atmosphere around a red dwarf star would likely scatter light differently, creating a sky of pale yellow, or a dim orange, or perhaps a muted butterscotch color. The age of this world is its most defining characteristic. It has existed for billions of years, longer than Earth. If life began here, it has had an immense head start. Imagine the life that could evolve with twice the amount of time. The quiet stability of the star would have allowed for long, uninterrupted periods of evolution. The life here could be ancient, complex, and perfectly adapted to its tranquil environment. In the copper-colored oceans, life might have evolved intelligence and forms far beyond our comprehension. The forests, with their dark, red, absorbing foliage, might be part of a single planet, spanning organism, a collective consciousness that has existed for eons. This world would feel old. You would sense it in the air, in the soil. It would be a feeling of deep, abiding peace, of a world that has found its balance and has maintained it for billions of years. Earth, by comparison, is a vibrant but chaotic teenager, still shaped by dramatic geological and climatic shifts. Teagarden's star B is the calm, wise elder. A different rhythm of time, the short year, would create a fascinating rhythm. Imagine a world where the full cycle of seasons, if it has any tilt, passes in just a few days. Life would need to adapt to this rapid cycle. Plants might grow, fruit, and seed in a matter of hours. The entire pulse of the ecosystem would be incredibly fast, yet set against the backdrop of a world that is geologically ancient and stable. It is a beautiful paradox, a world of fast life cycles existing in a state of deep, geological time. Let us sit on this hillside for a moment longer. Feel the perfectly familiar gravity. Enjoy the pleasant warmth on your skin. Gaze out at the tranquil, copper-colored sea under a butterscotch sky. There is a profound sense of peace here, a feeling of a world that is content. It is so much like Earth in its physical parameters, yet so profoundly different in its age, its light, and its rhythm. It is a gentle twin, a world that whispers of the possibilities of life finding a quiet harbor in the cosmos and thriving there for ages untold. With this feeling of deep tranquility, we gently pull away, leaving this ancient garden world to its peace, and begin the final leg of our journey. Part 5, The Lonely Pioneer Kepler, 186 for journey of 500 light years. Our final journey is our longest by far. We must cross a vast chasm of space, 500 light years, to reach the system of another red dwarf, Kepler 186. This distance is so immense that the light we see from this star tonight on Earth began its journey around the time that Leonardo da Vinci was painting the Mona Lisa. Our destination has a special place in history. It is the planet Kepler 186, and it was the very first Earth-sized planet to be discovered within the habitable zone of another star. It was a pioneer, a landmark discovery that proved to humanity that worlds like our own were not a cosmic rarity. As we arrive, we see a world only slightly larger than Earth, about 10 bigger. Its gravity would be almost imperceptibly stronger, a comfortable and familiar embrace. But this world is different from the others we have visited. It orbits on the extreme outer edge of its star's habitable zone. A world of perpetual autumn. Kepler 186 receives only about 1/3 of the energy that Earth gets from our sun. If you were to stand on its surface at high noon, the brightness would be similar to how it looks on Earth just 1 hour before sunset. This is a world of dim, fading light. A cold world, teetering on the edge of becoming a permanent ice planet. Let us imagine descending onto its surface. We find ourselves in a vast, quiet forest. The air is crisp and cool, with a permanent chill, like a late autumn afternoon on Earth. You can see your breath misting in the air. The star, Kepler 186, appears as a small, reddish range point in the sky. It offers little warmth, its light filtering down through the canopy of the forest. The foliage here would be dark, perhaps even black, desperate to absorb all the available light energy. The forest floor is a carpet of dark, alien mosses, damp and cool to the touch. The color palette of this world is muted and somber. The sky might be a pale, washed out orange. The oceans, if they exist, would be a deep, dark grey, their surfaces often covered with thin sheets of ice near the shores. This is a melancholy, beautiful world, a world of permanent twilight and encroaching cold. A longer, slower year. The planet takes 130 Earth days to complete one orbit. Its year is slower, more deliberate than the frenetic years of the worlds closer to their stars. This would give the world a sense of a slower, more ponderous rhythm. The seasons, should the planet have a tilt, would be long and subtle, a slow slide from the cool of summer to the deep cold of winter. Given its position, much of Kepler 186 could be covered in massive glaciers, great sheets of ice that grind slowly across the continents. Liquid water might only exist in a narrow band around the equator, creating a single, temperate belt where life could thrive. Imagine standing on the edge of one of these immense glaciers. It is a wall of ice, kilometers high, glowing faintly under the dim orange sky. You can hear the slow, groaning creak of the ice as it moves, the sound of geology in action. It is a sound that speaks of immense timescales and incredible power. Life on this world would need to be hardy, adapted to the cold. Creatures might have thick fur or layers of insulation. Plants might grow very slowly, conserving every bit of energy they can glean from the distant reddish sun. It would be a world of survivors, a world where life clings on with a quiet tenacity in the face of the encroaching cold. A solitary world unlike the Trappist-owned system, with its family of celestial neighbors. Kepler 186 is the outermost of its 5 known planets. Its siblings are far away, appearing as little more than bright stars in its sky. It is a world that, much like Earth, would feel more solitary in its cosmic journey. This pioneering world, the first of its kind we ever found, serves as a poignant final stop on our tour. It is not a tropical paradise or a world of perfect familiarity. It is a stark, cool, and perhaps challenging world for life. And yet, it is beautiful in its own right. It reminds us that the habitable zone is not a guarantee of comfort, but simply a range of possibilities. Let us stand for a final moment in this cool, quiet, autumnal world. Listen to the silence of the dark forest. Feel the crisp chill in the air. Look up at the small, dim sun that provides just enough energy for this world to harbor the potential for life. It is a world on the edge, a world of quiet beauty and incredible resilience. Conclusion: the return to the blue marble. Our journey is now at its end. Let us slowly, gently, pull our consciousness back from the far-flung shores of these alien worlds. Back across the 500 light-years from Kepler 186, past the heavy gravity of Wolf 1061c, away from the ancient peace of Teegarden's star B. We drift past the family of worlds in the Trappist-owned system and leave the eternal twilight of our nearest neighbor, Proxima b, behind us. We are traveling back home. And as we approach our own solar system, we see a familiar light. Not a dim red ember, but a brilliant, dazzling, golden star, our sun. And circling it, we see a sight more beautiful and vibrant than any we have witnessed on our journey. A swirl of brilliant white clouds, deep blue oceans, and continents of green and brown. We see Earth. We have felt the heavy gravity of a super-Earth, and now we appreciate the lightness of our own. We have seen the dim, red light of other suns, and now we can feel the warmth and brilliance of our own yellow, white star. We have imagined skies crowded with other worlds and skies with motionless suns, and now we appreciate the simple, beautiful cycle of our own sunrise and sunset, the rising of our solitary, silvery moon. Our journey to these 5 worlds has shown us the incredible diversity of planets that may exist. But more than that, it has shown us how truly precious and perhaps how truly rare our own world is. Let your mind now settle back into your body. Feel the familiar, gentle pull of Earth's gravity. Listen to the quiet sounds of your room. You are home. You have crossed the cosmos and returned, carrying with you the silent wonder of other shores. May these visions of other worlds bring you a deep and peaceful rest in the quiet miracle of our own.